Hi, Algebra 2. So this is the review for the semester final. You can find this in the back of your semester 1 book. Remember, you have both semesters of your book that are given to you. So um, let's run through this. It says list the domain of and the range of each of the following. So the domain is going to be the -3, 0, 1, and 2. That's the domain. And the range is going to be the y values, which is -2, -2, 1, and 0. Number 2, the domain is -1, 1, 0, 1. The range is going to be 4, 1, or 4, 0, excuse me, 2, and 3. Determine the relation is a function or not. So remember, we're looking to see, does the x repeat? So the x does not repeat here, so yes, this is a function. Number 4, looking at the x values, do they repeat? Yeah, we have 2, 1, so this is not a function. For each function, indicate, okay, so we want to plug half in, so we're going to get 2 times half, which is 1. 1 minus 3 is -2. On this one, we are going to do, they want us to find both, so plug 3 in, so that's 9. That's 54 minus 3 minus 2, so that's going to give us 49 if we plug -half in. So that's going to get that 6 times a fourth, because if I square -1/2, plus a half, because you have negative minus 2. And if you do that math on your calculator, you should get that pretty easily. I don't have a calculator that I have open right this moment, so. All right, graph each of them. So I have -2 down here. I'm going to go up 1, right 2. Graph our line. Our domain is going to go negative to positive infinity, as well as our range, because it goes straight, it goes up and down as well. This one I use our cover method, so I'm going to go 0, blank, blank, 0. So that's going to give me a 4 there. So 0, 4 is here. I'm going to cover up the y. That's going to give us 6 here. So we have a 6 right there. Connect the dots. The domain negative to positive infinity, as well as the range, because it does go up and down. And this one, let's see if we wanted to graph it. It's kind of hard to graph it as it sits, so I'm going to go 2/3 y equals -4, multiply both sides by the 3, so I get -12, divide each side by 2, so I get -6. So this is going to be a horizontal line down here. It's -6. And our domain goes negative to positive infinity. Our range is just -6. That's the only y value you can get out of the problem. All right, so next page. All right, the absolute value. So remember, these look like a V. So if it's inside, it's going to shift left or shift right, and then up 1 to 1. So our domain goes negative to positive infinity. Our range is going to go from 0, because it's on the x-axis, to infinity. On this one, it's going to go down -3. It's going to grow twice as fast, so up 2, right 1, left 2, right 1. So it's a little bit tighter V. Our domain goes negative to positive infinity. Our range goes from -3, that's a -3, to infinity. On this one, it's going to shift left 4, up 2, and it's going to grow down. So right 1 down 3, left 1 down 3. So our domain goes negative to positive infinity. Our range goes from -infinity, remember bottom to top, to +2, square bracket. For each of the following, determine if we have a function. So this would look like a parabola, so yes, it is. Okay, the y values don't repeat. This is a straight line, so yes, this is a function. This is not going to be a function. We have one of the obscure things. So the y value can, or the x values can repeat, so this is not a function. You can also see it when you graph it on a calculator. This one's going to be tougher to graph. You'd have to solve for y. Find the equation of the line. So we're going to plug in a point slope first. So I'm going to get y minus 7 equals -2, x minus 3. And this is the equation just like that. We might have to solve it for, we can multiply everything by the 2 and then add 7 to it. So that becomes a 13. So y equals that. And this one, I'm going to get y minus 2 equals, again, plug it into point slope, x minus 3. I'd probably keep this one just like this. I mean, I could multiply, let's see, if you multiply the negative 4/3 over the parentheses, that's going to give you plus 4, and then add 2, so that's going to give you 6, so y equals 6. Find the equation, a line containing the two sets of points. So let's find the slope first. So our slope is going to be -1 minus 14, -1 minus 2. So that's going to give me -15 over -3. So that's just 5 as a slope. Then pick one of the sets of points. So I'm going to get y plus 1 equals 5, x plus 1. And solve that, just multiply over by 5, divide by, or subtract 1. Find the slope of this one. So I'm going to get 0 minus 4, which is 4. -4 minus 4 is -8. So we have a slope of -1/2 here. If we plug this one in, I'm going to get y minus 0 equals -1/2 x plus 4. If you multiply this over, this will give you half x minus 2. That's what y is equal to. This particular one, because our y values repeat, just y equals 7. This one, because our x values repeat, it's just going to be x equals 15. Determine if these are parallel, perpendicular, or neither. So we have to look at the slopes. The slope of the top one is going to be 3/4. If I divide everything by 3, I'm going to get -4/3. Those are opposite reciprocals, so these are perpendicular lines to each other. On this particular one, if I subtract 3x and divide by 4, I'm going to get -3/4 for a slope. This one has -3/4, so these are parallel. These, if I solve for y, I'm going to get 3/5 for the top slope. On bottom, I'm going to subtract 5. And so this one is neither, because the slope is not that. So you're solving for y on each of those, looking for what's attached to the x for the slope. Write the equation containing a given, so parallel. So if I add 3 to both sides, I'll find my slope is 3. I'm going to get y minus 2 equals 3x plus 2. Multiply over and add. So I'm going to get 3x plus 6, add 2 plus 8. We want perpendicular, so I'm going to solve this. So it looks like our slope would be 2. So our perpendicular slope would be -1/2. We're going to plug this into point slope, so I'm going to get y plus 3 equals -1/2 x minus 4. Let's multiply the half over the parentheses. So I'm going to get -1/2 x plus 2, subtract 3, so -1. So this is perpendicular to the given, and also contains the point 4, 3. All right, so on this one, we want to plug 2 into our g equation. So 2 minus 3 is -1. Then take -1, plug it in there. -1 squared is +1. On this one, I'm going to plug -1 to h, so that's going to give me -2, because 2 times -1. And then I'll plug that in, so I'm going to get -2 minus 3, which is -5. This one, we want to plug g at x in, so I'm going to get x minus 3 quantity squared, FOIL that out. That's x squared minus 6x plus 9. I want to plug g at x into, nope, I did that one there. I want to plug g into h at x. So g at x into h at x is going to give me 2x minus 3, which is going to be 2x minus 3. So this is this answer here. I kind of went backwards. Sorry about that. All right, so 98 is going to break down to 49 times 2, so that's 7 with a root 2 in there. I can take out an x, because that's x squared x. It leaves me an x inside. The y stays inside. Square root of z squared is z. That one's done. Third root of 64, so 4 times 4 times 4 is 64, so third root of 64 is that. Third root of x to the third is x. Third root of y to the sixth, 3 goes into 6 twice. And there's no remainder, no radical. Fifth root, this is going to give me -2, and then I can factor out an x, and that's going to leave me behind an x squared, and there's a fifth root of x squared there. When we start getting into these, you can multiply them out, or you can start realizing, okay, 18 is 9 times 2. 72 is 9 times 8. 8 is the same thing as 4 times 2. So the square root of 9 is 3. Square root of 9 is 3. Square root of 4 is 2. So 3 times 3 is 9 times 2 which is 18. And then I have root 2 times root 2, which is root 4. Root 4 is 2, so that's going to come out to 36. So everything cancels out. On this one, the 10 can break down to 5 times 2 times x. So you have two 5s underneath, so you have a 5 that comes out. X squared comes out as squared x squared that, and then I'm left with just root x. On this one, you want to reduce it first, so 8 goes in 72 9 times. Tug of war with the a's, so I get a to the second. Tug of war with the b's, I get b, so this is going to give me 3a square root b. On this one, we want to reduce it, so let's see, 12 goes into 96 how many times? It goes in 8 times. So I'm going to wind up on top. Oops, I don't know what this is. I'm going to get third root of 8, tug of war at the a's. So a squared, tug of war at the b's. I get this. So third root of 8 is 2. And then I left behind, I have third root of a to the third b. So I don't have any 3 of a kinds. Third root of 64 is going to give me 4. Third root of 27 is 3. So that one's done as that. This is going to break down to 16 times 2, which is going to give me 4 root 2. This is going to break down to 4 and 2. Square root of 4 is 2. Multiply the outside 2, so I'm going to get 4 root 2. Square root of 18 breaks down to 9 times 2, so square root of 9 is 3 times that 12. And so now we have all like terms, the same radical. So 4 plus 4 is 8. 8 minus 12 is negative 4 root 2. If I FOIL this one out, I have 2 of these equations, so I'm going to get 4 root 36 plus 6 root 42 plus 6 fourth root of 42 plus 6 fourth root of 42. I think I did that right. Hang on, I think I messed up on this. Let's see, can I even expand that? It's not going to let me expand. Okay. All right, so 2 root 6 plus 3 root 7. 2 root 6 plus 3 root 7. FOIL it out, so that's going to give you 4 root 36. 36, that's going to give me 24 for the first thing. And then multiply the outside, that's going to give me 6 root 42. Inside, that's going to give me 6 root 42. And the last one's going to give me 9 root 49. Root 49 is 7, so that's 63. 42 is not going to break down. It's 2 and 21. 2 is 3 and 7. It's not going to work. So 24 plus 63 is 87 plus 12 root 42. If I distribute here, that's going to give me 4 root 3. Root 3 times root 3 is root 9. Root 9 is 3, so that one's done. If I FOIL this one, I'm going to get 6 root 49. Root 49 is 7, so that's going to give me 42 because 7 times 6. Then outside, that's going to give me 6 root 14. 14 is not going to break down. And then inside, I'm going to get 12 root 14. And last, I'm going to get negative. That's 12 times root 4. Root 4 is 2, so that's minus 24. So 42 minus 24 is going to give me 18 minus 6 root 14. Right, without rationals. Okay. So we want to put this in as a radical. So I have the 5th root of 32 raised to the 3rd. The 5th root of 32 is 2. 2 to the 3rd is 2 times 2 times 2, so that's 8. You can plug that directly into a calculator. It's going to work out. This one, we're going to get the 4th root of m to the 5th, n to the 3rd. M to the 5th is going to break down. A single m comes out, and then we'll have left behind an m and an n to the 3rd, and it's 4th root. Write this. So this is going to become x to the 5th. Oops, x to the 1/5, y to the 1/5. It also might be xy raised to the 1/5. This one is going to be the 20 raised to the 1/3 power. That's not going to break down any further. That's just how we're going to do it. Pages, we got lots. Okay. All right. Like bases, add the exponents. So 1/2 plus 3/5 comes out to 11/10, so x to the 11/10. Just add the exponents. We're going to subtract the exponents here, the same basis, so 5/8 minus 3/8. So that's going to be 7 raised to the 1/4 power. Power to power, multiply the exponent, so that's going to give me x to the 6/25. That's done. All right, we're going to square both sides here, so I'm going to get 5x minus 3 equals 2x plus 3. Subtract 2x, that's 3x. Add 3, so that's 6. Divide each side by 2. Make sure I don't get a negative answer, so x equals 2 here, so I get 10 minus 3. That's fine. Cool, that's no extraneous solutions. Raise each side to the third power to get rid of that. So 2 to the third is 8. Subtract 5 from both sides, so I get 3. If I plug 3 in, that works. That's our answer. This one, let's square both sides. So I'm squaring that, so I'm going to get positive 25. Add 3 to both sides, which is 28. If I plug 28 in, I get 28 minus 3 is 25. Square root of 25 is 5. This doesn't work. It's an extraneous solution, so there's no solution to this problem. For this particular problem, I bring an I out, so I get 4i squared. I squared is -1, so I'm going to get -4 root 3. This is going to give me root 45. The negatives go away. When 45 breaks down to 9 times 5, which is 3 root 5. This one I'm going to get 36i. For this one, we're going to just add like terms. So -3 plus 5 is 2. 3i plus 6i is 9i. This one I'll distribute the negative over first. So I'm going to get 2i plus 3i, which is 5i minus 4. On this one, I'm going to get -9, because if I distribute that negative over, plus 5i. This one, if I FOIL it out, let me move it down. This is going to give me outside, or at first, 10 plus 4i plus 5i plus 2i squared. 2i squared is going to be -2, so 10 minus 2 is 8, and that's a plus, so plus 9i. This one, if I FOIL it out, I'm going to get 8. Outside is 4i, inside is 6i. Last is going to be 3i squared. 3i squared is going to be -3, so 8 minus -3, or 8 minus 3 is 5, plus 10i. This one, if I FOIL it out, I have this twice. So I'm going to get 4. Outside is -4i, inside is -4i, and last is going to be 4i squared. 4i squared is going to be -4, so 4 minus 4, those cancel. So I just get -8i. All right, so that's the subtraction sign. So this is going to be 5y minus z and 5y plus z. That's perfect difference of 2 squares. This one, let's see, I could factor a 9, and I have to change the order. So can I factor a 9 out? Well, it looks like I can factor a 3 out. That's going to give me 9a squared minus 10a plus 25. Those are perfect squares, so this is going to give me 3, and then 3a minus 5, and 3a minus 5. This particular one, what two numbers multiply to give me -10, add to give me +3, so +7. Oops, +5, excuse me. And -2. This one, these are perfect cubes, so this is going to give me 2t plus 10s, which is, and then I have to square it, so I'm going to get 4t squared minus 20ts plus 100s squared. If I factor this one, what two numbers multiply together to give me -24, and add that, so it's -8x plus 3x. So that's going to give me 2x, x minus 4, plus 3, and x minus 4. So this is going to be 2x plus 3, and x minus 4 for an answer. This one we have 4 parts, so factor by grouping. So I have a 2x squared. That gives me 2x plus 1x plus 2. Factor out a negative 8, and that's going to be x plus 2. So this is going to factor down to 2x squared minus 8. So I'm going to factor a 2 out first, and that's going to give me x squared minus 4. So that's going to break down to x plus 2, x minus 2. And then you have that last x plus 2. There's your answer. Again, make sure you ask your teacher if I didn't go over some of these or I went too quickly. We want to solve what two numbers multiply to give us positive 7, add to give us negative 8, set those equal to 0, so x equals 7, x equals 1. This one, I'm going to take the square root of both sides, so that's going to give me 6z equals plus or minus 11. Divide each side by 6, so plus or minus 11 over 6. This particular problem, I'm going to bookend it. The two numbers multiply together give me negative 12. Add to give me negative 1, so that's negative 4x plus 3x. So that's going to give me 2x and x minus 2. Factor out a 3 and x minus 2. So I get x equals 2 and 2x plus 3, subtract 3, divide by 2. This one, number 71, says Kim is installing a skylight to conserve energy. She wants the width 50 centimeters less than the length of the total area, 15. Okay. What are the dimensions? So we have a rectangle, we have length, we have width. She wants the width 50 less than the length. So if the length is x, I want the width to be 50 less than that. So I'm going to get x times x minus 50 equals 15,000. And then that's going to give me x squared minus 50x minus 15,000. So honestly, if you were to graph that on a graphing calculator, you're going to go x squared minus 50x minus 15,000. Never mind, I'm not going to do that. So let's see, what two numbers multiplied? So I need the factors of 15,000. Okay, so I got 1 in 15,000. So I got to go, I'm going to break 15,000. I'm going to go kind of aggressive. So 15,000 divided by 25 is 25 and 600. Okay, that's still too big. Okay, so let's go 100, 15,000 divided by 100. So that's 100 and 150. So I'm looking for what are going to add up to that. So I'm going to get x minus 150, x plus 100. Set those equal to 0. So x equals 150. This one won't work because it'd give me negative 100. So the dimensions, if I have the length is going to be 150. The width is 50 less than that. And there's your answer. All right, so describe the parabola. Okay, so this opens up, and then we have a vertical compression of 2/3 because that's out front. This one is a parabola that opens up. This is a parabola that opens down, has a vertical stretch of -3. Determine the vertex. Okay, so remember we're going to use negative b over 2a. Again, you can use your calculator on this, so if you do this, that's great. But the vertex is going to be 6 over 6, so 1 comma something, plug 1 in. That's 3 minus 6 minus 2. So that's -8. So that's going to give me that. Determine the vertex. And the y-intercept of this would have been 0, -2. The y-intercept of this one is 0, negative 12. If I go negative b over 2a, so I'm going to get negative 8 over 2 times negative 1. So that's going to give me negative 8 over negative 2. So it's going to be 4 comma, plug 4 in. So that's going to give me negative 16 plus 32 minus 12. So negative 16 plus 20. So 4, 4 is our vertex. Identify the vertex of this one. So it's in vertex form. So it's opposite. When it comes out, same there. Vertex here. It's not going to shift right or left. It's going to be just 0, 5. Write the equation of the parabola, vertex, and the point. I don't see these being on the final, so we're going to skip those. Solve the quadratic. So what's your numbers multiplied to give you negative 3 and add to give you positive 2. Set those equal to 0, so x equals negative 3, x equals negative 1. Oops, wait, I made a mistake. That should be a negative here, so that's a positive 1. Solve this one, so let's divide everything by 2 and bring the 10 divided by 2 is 5, so minus 5. So you're going to get 3x squared and minus 5. All right, what's your numbers multiplied to give me negative 15? Add to give me 2. So I'm going to get plus 5x minus 3x. And if we solve that, that's going to factor an x out. And so I'm left with 3x plus 5. Factor a 1 out, 3x plus 5. So you're going to get negative 5/3 when you set that equal to 0 and 1. Those are my solutions for number 82. This one, let's bookend it. So 5x squared minus 2. What's your numbers multiplied to give me negative 10? Add to give me 6. That one is not going to work. This is probably a quadratic formula one. So I'm going to get x equals negative 6 plus or minus square root b squared, which is 36 minus 4. Minus 4 times a is 5 times c is negative 2. So that's plus 40 all over 2a. So I'm going to get negative 6 plus or minus. That's going to give me root 76 over 10. Does 76 break down? Yeah, it breaks down to 419. So that's going to give me negative 6 plus or minus 2 root 19 over 10. These are all divisible by 2, so I'm going to get negative 3 plus or minus root 19 over 5. Okay, use synthetic division to see if we have roots. All right, so I'm going to divide by 1. So I have 1, negative 6, 11, and negative 6. Bring that down. 1 times 1 is 1. That's negative 5. Negative 5 times 1. That's going to give me 6. 6 times 6 is that. I get 0. So yes, that's a root because I get a remainder of 0. We're going to try negative 2 as well. So I got 1, negative 6, 11, and negative 6. Bring the first number straight down. 1 times negative 2 is negative 2. That's negative 8. That's positive 16. That's going to give me 27. That's going to give me negative 54. So that's going to give me negative 60. So this is not a root because I have a remainder. Use synthetic division to completely factor out. So I would graph this one first, being you have a graphing calculator. So you have x raised to the third plus 2x squared minus x minus 2. And if we graph this, it's going to show that it looks like, so positive 1 is definitely a root. So I have 1, 2, negative 1, negative 2. Bring this straight down. 1 times 1 is 1. That's 3. 3 times 1 is 3. That's going to give me 2. 2 times that, 0. So this is one of our factors. This is going to be x squared plus 3x plus 2. What two numbers multiply together to give me 2? Add to give me 3. It's these. So I'm going to get x equals negative 2 and x equals negative 1 as my other roots. So those 3 are our roots. Okay. Again, it might be multiple choice question, so if you just graphed it and you found where it crossed. Use synthetic division to find all 4 solutions. Again, I would graph it first on the calculator, so I'm going to get x to the 4th minus x to the 3rd minus 19x squared plus 49x minus 30. And if you graph this on the calculator, looks like 1, 2, 3, 4, 5. So -5 is definitely one that's going to work. So I have 1, -1, -19, 49, and 30. Bring this straight down. It's -5, so that's going to give me -6. That's going to be 30. And multiply that, that's going to give me 11. That's going to be -55. That's going to give me -6. That's going to give me -30, which is 0. So that's one solution. Okay, when you're looking at your graph, it looks like 1 is also going to work. So I'm going to synthetically divide 1 on this part. Forget about that. So bring the 1 down. 1 times 1 is 1. That's -5. -5 times that. That's going to give me 6. That's going to give me +6. That's 0. So that's another solution. It looks like 2 will also work. So let's bring 2. Bring that down. 1 times 2 is 2. That's -3. That's going to give me -6. I get a 0 there. Got that. So that's another solution. And then you got 3 that looks like it'll work. So that's going to give me 1. 1 times 3 is 3. That's 0. So there's my 4 solutions. Again, if you have the graphing calculator, la-ti-da, it's working out for you. All right. Use synthetic division to find all the solutions. Again, I would plug it into the calculator first. So you're going to get x raised to the 3rd minus 6x squared plus 3x plus 10. So if you graph this, you're going to find your solutions as it comes up. Looks like -1 is going to work. So if you made your xy axis, so -1 is going to work, 2 is going to work, and 1, 2, 3, 4, 5, and 5 is going to work. And then we have a y-intercept up here at 10. So your solutions are -1, 2, and 5. Okay, do the same one on number 89 using your graphing calculator. You can sketch it. Write the factored polynomial functions and zeros on the graph. So this looks like -3. This looks like a 0. We have a bounce here at 2. So I'm going to get x plus 3. And then x at 0, so just an x there. I have a bounce there at 2, so that's x minus 2 quantity squared. So distribute here, that's going to give me x squared plus 3x. FOIL x minus 2 out, so that's going to give me x squared minus 4x minus 4. You multiply this all out, I'm going to get x to the 4th minus 4x to the 3rd minus 4x squared plus 3x to the 3rd minus 12x minus 12 x squared minus 12x. All right, so I have x to the 4th minus x to the 3rd minus 16x squared minus 12x is that answer. In this particular one, we have -1 that is taking place at, and then we have a bounce here at 3. So that's going to give me x plus 1 and x minus 3 quantity squared. So if we multiply that out, that's going to give me x squared minus 6x plus 9. Then multiply the x over, so x to the 3rd minus 6x squared plus 9x plus x squared minus 6x plus 9. So I'm going to get x to the 3rd minus 5x squared plus 3x plus 9. All right, so these, we want to make sure we plug these in to the graphing calculator. So I'm going to write these matrices down so I can plug them in. I'll pull up a calculator here. This is H, so -1, -2, 5, 1, 0, -1, -2, -3, and 1. J is -2, 3, 4, 8, 0, -1. M is going to be -3, 5, -2, 1, 0, -4, -2, -3, -5. P is going to be 2, -3, -1, and 4. Q is going to be -3, -3, 7, -5, 2, and 1. And R is going to be -1, 0, 0, 2, -3, and 5. All right, we need to plug all those into our calculator, so I'm going to take us over to a graphing calculator. And of course, you have one in your hand. I'm just using the one on the computer so we can see it on screen. It's thinking about it. It's trying to get there. All right. So first thing you want to do is you're going to go into, you're going to hit second matrix. And we're going to start naming them. So edit the first one. It is a 3 by 3. And so this is going to give me -1, -2, 5, 1, 0, -1, -2, -3, and 1. Once you have that in, hit second quit, go into your matrix again, second matrix. We're going to edit the second one now. So J is a 2 by 3, 2 rows by 3 columns. So that's going to give me -2, 3, 4, 8, 0, 1. Enter, and then quit out of that. And then second matrix, edit the number 3. Number 3, that's M, that's a 3 by 3, not a 33. 3 by, nope, make a mistake, just go back up to 3 by 3, not by 3 by 9. Holy cow, that's huge. And so that one's going to be -3, 5, -2, 1, 0, -4, -2, -3, and -5. Quit out of that. Second matrix. We want to do P now, which is a 2 by 2. Oops, clear. Edit number 4. It's a 2 by 2. And that's going to give me 2, -3, -1, and 4. Get it all in there. Second quit out. Second matrix. Letter Q is a 2 by 3, so we're going to edit number 5, and that is a 2 by 3. So I'm going to get -3, -3, 7, -5, 2, and 1. Let's quit out of that. And the last one, it's back to second matrix, edit. This is number 6. That is a 3 by 2. Oops, not a 33. Oh my gosh, we made this one enormous. 3 by 2. Head on down, so I'll get -1, 0, 0, 2, not 32. Sorry about that. -3 and 5. As long as I plug these in right, we should get some magic. So quit out of that. All right, so let's go back to our screen. So this is matrix 1, 2, 3, 4, 5, and 6. Okay, so first one we want to do, what are the dimensions of Q? So Q is a 2 by 3. Matrix R is a 3 by 2. So it's rows by columns. Okay, and then find the following: H plus M. So H plus M. So H plus M. So you can just, so 1 and 3. There's H plus on 1 and 3. So you're going to go matrix 1 plus matrix 3. You add those together, there's your answer right there. Okay, so let's go back to our grid, and then we want 3J minus 2Q. So that's number 63. We want number 64 to be J times M, number 65 to be R times Q, number 66 H plus J, and number 67 we want J times Q. All right, so we can do all these just on a calculator. All right, so number 63 we want 3, and then we want matrix J. Matrix J was the second one. And then I want minus 2Q. So second matrix. Notice I have the numbers there. Q is number 5. Hit enter. There's your answer for number 63. Number 64, we want J times M. J times M. So we are going to go second matrix. J is our second matrix times M, which is our third matrix. Multiply those together. And there's your answer. Number 65, we want R times Q. So R is number 6 times Q, which is number 5. And there's our answer for R times Q, which is 65. And then we want H plus J. So H is our first matrix plus J is our second matrix. And something's going to happen here. Ready? Boom. The dimensions don't match. Okay? H is a 3 by 3. You can't add a 3 by 3 to a 2 by 3, so that one's not going to work. So quit out of that. Then last one, we want J times Q. So second matrix, letter J is our second matrix times Q, which is our fifth matrix. And again, the dimensions didn't match. So J is a 2 by 3 and Q is a 2 by 3. The inside dimensions don't match, so that's not going to work. Okay? And then we have all the answers down below for the next couple pages. So if you look at those, perhaps you can utilize those answers to help you out, but hopefully this helps you on this. Have a great day. Make sure you talk to your teacher if you need extra help on any of these things. Hopefully I've made it correct. Take care of one another.